Hey, hello. I'm Freddy Machado, and welcome to the stream or to the YouTube video. Because when I finish this, I'm going to upload this to YouTube. And yeah, we hope we have a great time today. Because we're going to write Fortnite replay reader. And yeah, I think it will be very nice. So, first of all, let me talk about the Fortnite replay, because it's an Unreal Engine format. Because of course, probably you know that Fortnite is made using Unreal Engine from Epic Games. So let me just lower the volume a little bit. Okay. So I have access to the Unreal Engine source code, and you can have access to. You just need to link your Epic Games account, your Fortnite account maybe, with oh sorry, it's the opposite. You have to link your GitHub account to your Epic Games account. So then after that you have access to the Unreal Engine source code. And so you need to clone that and then follow the getting up and running. So you have to run a couple of batch files, and then you get the solutions, the solution to open. So I have it here. I'm opening it in Visual Studio 2017. You can open it in the Community Edition, which is free. So it's fine. And what I did was, after opening the Unreal Engine source code, I did a search. So let's do it. So I was searching for .replay, which is the extension of the replay file. So only CPP files. And then we're going to find the class that does all the job for us. So we can start from that. We can see the structure of the replay file, which helps a lot. Okay, so this is the code: local file network replay streaming. And if we can have a look at that, and then we can see some enum, some code here, file magic. This one is important. So what we can try to find is the function, the method that reads the replay info, which is this one. So this is where the magic happens. So you can see here that we have some local variables. uint 32 bits, unsigned int 32 bits. So we know that 1 byte is 8 bits. So 32 is 4 bytes. And these operators here are reading 4 bytes in this case to this magic number local variable. And you can have some clues here. So it checks if it's the same as file magic. So the first 4 bytes are the file magic. And then we start reading some data. So yeah, we can try to open this in a hexadecimal editor. I have some replays file here. I have this one that I know that I won this match, so I was first place, like out of, I don't think it was 100, but it was a lot, 90 something, I guess. So you can see the first 4 bytes, 7F, E2, A2, 1C. So let's check the file magic. And yeah, we can see that it's in the opposite order, right? So it's 1C, A2, E2, 7F, 1C, A2, and C8, 2, E2, 7F. Okay, so this is because the byte order here in this file is little endian. So you can try to find something like little endian versus big endian to know more about this. But essentially for little endian byte order, the least significant byte is placed at the lowest address, so at the beginning of the value. Okay, so 7F is the least significant byte here. And for strings, you can see that it looks like it's not inverted, but that's because for ASCII strings, every character here is 1 byte, so there's no reversing here. There's no need for reversing here. But for Unicode, which is 16 bits or 2 bytes, then you can see that 00 is after 55. So the least significant byte is here, right? So it should be 0055 if it was big endian. Okay, so let's try to read this in C#. So I'm going to create Fortnite replay reader. I have a Visual Studio Code, which is free, so I recommend that. We're going to use .NET Core. So let's use .NET new console. Should be good to go. Okay. Let's try to run this just to see if everything is working. Cool, hello world. Okay, so let's try to like convert this C++ code here to C#. First thing, we need to know that all the replay files are stored in the local app data folder. So see your users directory, your username, app data, local, and then Fortnite game, saved, demos. So all the replay files are here. So we can try to open files in there. Something like this, replay files equals directory. Let's do control dot and bring system.io. Enumerate files. Then we can use the verbatim sign here. Otherwise, we would have to use like double forward slashes, and I'm not a fan of that. Okay. So after that, we can pass a pattern, which is dot replay. Okay, everything dot replay. We can maybe try to see which files we have there. Console.writeLine. Then we can run this and have a look what do we got. Okay, all the replay files. So I know that I won in this. I got first place in this one. So I'm going to hard code this for now. But later we are going to to change this. I'm going to use this as a base just for us to read the file. So to read this file, it's a binary format, so we need a binary reader. I'm going to use the using directive. No, the using statement, not the directive. This is the directive. This is the statement. So using a binary reader. Sorry. We're going to use, I have some code here. Just in the binary reader and then get the stream from file.open. It's fine. Then the file mode should be open. All right. So the first thing we need to do after opening this is getting the magic number. Okay. We can maybe check if the total size is different than 0, but I'm not going to now. So we know that the first value in there is the magic number, okay? So we can simply do like var magic number equals reader dot read uint 32. We're essentially reading the same amount of bytes here, so should be fine. We can try to print this. And see what we get. Okay, got a big number. And we can try to put this in a calculator to see what it is. Just to make sure that we're reading the correct stuff. So 1C hexadecimal, sorry. 1C A2 E2 7F. Okay, so in decimal is this number here. And it's the exact same number we're getting here. So when we read the information, so it doesn't matter if it's little endian because we don't need to do anything. Like it's already there. It's all good for us. So we need to read this, and then we can read the next data, which is the file version, which is a uint32 as well. File version is then we can do the same thing, check the magic number. We can create a constant here. Except that uint32 is just uint in C#. So we can check that if magic number is different than this magic file magic here, then you can simply throw a new exception like replay invalid replay file. Okay, I don't really like ifs with lots of stuff inside of it. If the else probably is, oh, there's no else here, so it just ignores this file. But so I like to do something straight away if it's not equal in my case, instead of putting stuff inside of the if statement. But that's just my preference. So okay, so we read 8 bytes up to now. File version here for us is this 4 bytes here, so it's 5, the number 5. And then we can read this int 32, which is the length of the replay file in milliseconds. So we can read that. Thanks, Steve J. Gordon, for the follow. Thank you very much. I'm going to post this to YouTube later. So I know that the quality of my stream is not very good because I'm in Australia and I have less than 1 meg of upload. So yeah, it's not great, but I'm going to upload this to YouTube in a much better quality. So you can rewatch that if you want. Okay, so we're going to read the length of the replay file in milliseconds. Length in ms is good. And it's going to be reader.read int 32. It can be negative, but I don't know why it would be negative. It doesn't make sense. I don't know why it's not uint unsigned, in fact, but that's all right. So network version is a uint 32. So we can do that. Network version uint 32. And then change list is another uint 32. So this change list here is in fact the value that changes when Fortnite gets an update. So you're not able to rewatch your previous replay files when there's an update because they change this and they have a validation somewhere. And so we read 4 bytes, more 4 bytes, 8, more 4, 8, so 12, 16. So this value here starts on the offset 16. So you can see here the offset 16 is this one, 10 in hexadecimal, 16 in decimal. So this value here, this 4 bytes here, change on every Fortnite update. So one way that you can rewatch your previous replays is if you get a newer replay from the newest version, then you get this value from the new replay, and then you just put the same value in the previous replay files. I have a PowerShell script that I copied from a great guy called I am Luke Weiss, I guess. I have it here, my gist. I am Luke Weiss, yeah. He created this. I just updated these values here, so you can run this and it will fix all your replay files, so you can rewatch them in the current version. It's in my gists in GitHub. Okay, so we're reading the change list, and now we're going to read that NavString. Okay, FString is a little bit tricky. So friendly name. So friendly name. So for this, I'm going to create another file here. I'm going to call this binary reader extensions. I'm going to just grab these placeholders here. For now, it's going to be called binary reader extensions. Okay, and it's going to be a public static class because it's going to be made of extension methods. and it's going to return a string for us. Should be static as well. And I'm going to call this read FString. Okay. And it's going to extend the binary reader. So for this one, we need to do some investigation. This is a placeholder for now. So reader dot read FString. Okay. So how we're going to read this? So FString is class from Unreal Engine. So what we can do is, since we're using Visual Studio, and it's a great tool, you can see here that's there's an operator involved, this operator here, which is reading the FString, and we can press F12 here, which is go to definition, and this is amazing. You just in the definition of this overload here, this operator, and we can see here what it's reading. So first it reads an int 32, which means it can be negative, and we can try to have a look at this. So this is the change list, and then after that we have the friendly name. Okay, so this is 4 bytes. This 4 bytes here. So this seems to be a very big number, but in fact this is, you can see that this string is weird, right? Because it has 2 bytes per character here. So I know Unicode, and I know that Unicode has 16 bits, so 2 bytes, and this one seems to be ASCII, right? The default encoding. So this was a clue to me, and then I start reading this, and you can see here that after we read this int 32, which is the length of the string, it checks if it's less than 0. So if it is less than 0, then it's Unicode string. So you can see here, if this is greater than 0, it's ANSI, and if it's less than 0, then it's Unicode. Okay, so that's what we are going to do. But I'm going to call this length, just because. So we're going to read an int 32, and then we can do, I hate this, like var is Unicode, length is less than 0, and then if it is less than 0, then we can do something like this, length equals minus length. Okay, this is the same thing here that this thing is doing. If it's still less than 0, then probably there's the problem, the archive is corrupted. So I'm not going to bother with that. We could do it, but yeah, I'm not doing it now. Network packets allocating too much memory, I don't care about that. We're using C#, probably we're safe here, I hope. Sometimes not, but anyway. So just initializing the data, which does, we don't care about that. We don't care about this either. So if it is Unicode, maybe we can use the same thing here. So if it is Unicode, then we're going to read this amount of bytes, okay? So we can call this data. Use reader.read bytes in this case. The length. And then we can have a look at this data. Maybe we can do F5 and then we can run until we get here. Is it going to run? Oh, I don't have any configuration. Okay. Let me just try one thing. I'm going to reopen VS Code and then open the folder because we were in the code folder, not in the Fortnite replay reader folder. So it's user streaming code, this one. Then probably it's going to ask us to install some stuff. Or to create the things we need. Does anyone know how to create the I don't know what is it called? Okay. Okay, yeah, that's it. Thanks. Okay, let's do it. Yeah, the VS Code launch and tasks. Okay, that's it. That's all we need. Yeah, so I had to open directly the solution, the project folder. And then now we can go to debug and play. Put a breakpoint here. Hey Jeff, how are you? Fixed means, what do you mean fixed? Where is fixed? In the C++ code? Or? Okay. So we can see that we get all the bytes and this 0 here. Because most of these bytes are just using one. Most of these characters here, which is 2 bytes, are using only one, so the last one is 0. So what we can do for this, we can do something like this, encoding, which is in system.text, yeah? Coding.unicode.getString, and then use the data. So now we should be able to return this. We can return right here. Let's see, F5, run this. The fixed file name convention. And then the PowerShell script. This PowerShell script. Yeah, but I don't know what you mean about fixed file name convention. Okay, so friendly name is unsaved replay, which makes sense. It is an unsaved replay. So this thing here. Oh, sorry. I opened it with the binary reader, and then this thing loses the pointer to that file. Okay, so I have a bunch of data here. And what we need to do now is to trim it, right? So we can do something like can return like value dot trim, and then we're going to pass an array of chars. So it will be, we're going to remove the space and the trailing 0, the no character. The trailing 0 as well, because all the strings here have a trailing 0. You can have a look at that just to make sure. Oh, okay, yeah, the fixed. Yeah, because usually your replay files are going to be saved by default as unsaved replay, and then the date, okay? And what happens is when Fortnite releases an update, then you're not able to reload and rewatch your replay file from the previous version. So with this PowerShell script, you're able to update some bytes in those replay files, and then you can reopen them. But instead of like replacing the file, it's just creating a new file using the same name but prefixed with fixed, just so it doesn't overwrite your replays. Okay, so oh, what am I doing? So value.trim should trim my data. Let's trim this thing here and see what happens now. That's interesting. It's not trimming. Not trimming my code, which is pretty weird. Which is very weird. I'm wondering if this is something related to something in here. I'm going to try to run this. I still have the... Oh, I know why. Because when we are reading this, because this is Unicode, every character here has 2 bytes, not 1. And when we get the length of this string, we get the length of characters in the string, not the length of the actual 16 bits string. So we can see here that it's using the length times the size of this thing, which in this case is 16 bits. Okay, which makes sense. So we need to read the bytes times 2. Okay, and now it should work, hopefully. Okay, we're getting the value, and then with the trailing 0 in there, then the no character terminator. And voila, here it is, the friendly name, which is awesome. I'm much happier now. Cool. So we have the friendly name, and then the next thing we can do, we need to implement the other the ASCII implementation, but we can do it later. So here we have some checks. So if the file version is greater or equal to 1 in this case, so we can see these values here, 1. So if it's greater or equal to 1, then we need to read this. Trim the spaces. Okay, no, we don't need to read this. It doesn't matter for us. Yeah, this thing doesn't matter for us at all. We can read the is live because we are not to save. You're not going to save things in a like a struct or something like this. You're just going to read the file straight away for now, because my plan is to create a library, a NuGet package, so you can use this in any of your applications or something. But my real intent is to build a library using net standard 1.3, I guess, something like that, and then build CI and CD against that to make our lives easier, and to go through this whole stuff of building CI/CD pipelines, which is nice, and it's good to practice because it's not like every day that you have a chance to create one pipeline, and then you always forget how to do that. At least it happens to me, so we can remind ourselves how to do that. Okay, so the next thing we can read is live here, which is a new win32, and it's checking if it's different than 0, then it's not live. So we can do something that like this is live, and then we can do straight away the check straight away, like read win32 different than 0. Looks good to me. Okay, now if the file version is greater or equal to 3, in this case, this thing here, then we need to read a timestamp, which is an fDateTime, which, so we can do this check here. So if file version is greater or equal to 3, we're going to do some magic numbers here, like hard-coded numbers, just for now. We can change it later. So fDateTime, you can have a look at that and see that in 64, we can have a look at the reader operator here, and it is going to read ticks, which is int 64. Okay, so it's a long in C#. So if it's greater or equal to 3, then we're going to read the timestamp, which is read long, or read, in this case, int 64. We can check the timestamp if we want. We can do something like, since it's ticks, we can make sure that what it is, values of this type represents dates and times between midnight, blah 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 blah. Gregorian calendar, stored in ticks of 100 nanoseconds or 0.1 microseconds since January. Okay, that's a good clue for us. So it's ticks, then we can do something like this, date, time, and then use the ticks overload, which is okay, long ticks. This one, it's going to use these overloads, and then we can get the daytime of this thing, which is nice. So probably it will be the same date we have here, the 13th of July at 11:29 p.m. We can maybe try that and see what happens. We don't care about this anymore. And 13th of July of 2018, 11:29, 16 p.m. So all good. I'll leave this here inside of this if. It's not going to be used anywhere, so but I don't care for now. I only care about reading this data, which means that the reader, the stream is going to go forward 8 bytes in this case. That's the only thing I care for now. So now, if the file version is greater or equal to 2, okay, then we read another uint32, and we set this as a compressed variable. So if file version is greater or equal to 2, then is compressed equals to read uint32, different than 0. Okay, doing the same thing as this thing is doing. Total size of the file. Okay, now we're going to read chunks of data. So we can maybe try to see where we're at in the file. So if we put a breakpoint here, you can see the length of this FString, because this is the biggest thing we have in the file. So run this, and the length is 257. Okay, and 257 decimal is 101. Remember, it's Unicode, so we need to do ×2, so it's 202 in hexadecimal. So 257 ×2, so 514, and 202 in hexadecimal. So the string starts here, okay? So you can go 202. I don't know if you can see that, but in here we can see the length of the selection. So this is 202. So we know that the next 4 bytes is, oops, sorry. So the next 4 bytes is the isAlive. So isAlive is 0 in this case. And then we're going to read the next 8 bytes, which is int64. So until this offset here. And then file version. So file version for us is 5. Okay, 5. The next one is compressed in 32, so it's this thing here, which is 1, so it is compressed. We don't care about that, doesn't matter for us. But what we need to do that is loop through all the chunks of data. So we can have some clues here that archive.tell is going to get the position of the stream reader now. So we need to store that. So for us, let's do this loop here. So for us, this is while reader dot base stream dot position is less than reader dot base stream dot length. So we still have something to read. If it's equals to the length, then there's nothing to read anymore anyway. So we're going to do that, and then we're going to store the current position. So we can say offset. It's fine for me. In this case, it's the position of the stream now. Okay, it is a long. Okay, that's fine for us. So the first thing we read here is the chunk type. So we can have a look at what the chunk type is. It's enum, and it's a uint32, so it's 4 bytes. The first one is 0, then 1, 2, 3, and then this big number here. So we have header, replay data, checkpoint, events. So up to here, we have the replay file format. But the data inside of these chunks of data, it's Fortnite's data. So probably they have classes and structures to read this data and then do something like to be able to replay, to rewatch the replay file. So what we care about here for us is the events, because we are going to read the player eliminations and some other stuff like the position of your position in this replay file, how many players you killed, and stuff like that. So what we're going to do is read this uint32, which is the chunk type. So the chunk type here is uint32, okay? So now this is the interesting part. It's reading the chunk type and then storing the index, but these things are for the Unreal Engine's internal stuff. We don't care about that, at least for now. Then the next thing is a size in bytes, which is an int32. So we need that size in bytes. So it's the size of this chunk of data. We're going to use that later to advance to the next chunk. Then some checks, we don't really care about that. And then we select the chunk type. So as I said, we only care about the event. Yeah, we can try to do that. Yeah, that's a good idea. To see the place where most of people die. Oh, I have some wine here. I forgot about this. That's a good idea. Incorporate some data in analytics. That's interesting. Thanks. You can try to do that. Not today, though. Okay, so we only care about the events for now, right? This thing here. So we're going to reverse this. So if the chunk type equals to 3, which is event, then let's see what we need to read. We don't care about this. It's internal stuff. The ID. Okay, what's the ID? It's an FString. The group is an FString. Metadata is an FString. Time, uint. Okay. So we need the ID equals reader.read FString. This one will be interesting because this is not Unicode, so we need to implement this thing here. You can put a breakpoint here and then and see what happens. So F5, and then when it stops, we do F11. Oh, we don't need to because we have a breakpoint here. No, we need to. Okay. So the timestamp, we don't care. So you're going to read the ID. So now the ID. Oh, this shouldn't be the. This is going to blow up. It's a huge number. Okay, we need to do something else. Let's see what we have here. Okay, all right. That's because the first event is not 3, so we need to advance the amount of bytes of this chunk. Otherwise, it's not possible to read more data. So by the end of this thing here, we can have a look at Unreal Engine's code, and then we can see here that we seek the offset plus the size in bytes of that chunk. So we need to do the same thing, otherwise we won't be able to read this. So it's read.FString.seek, and it's going to be this thing here, offset plus the chunk, the size in bytes. So offset plus size in bytes. And also we need to do seek origin current. No, sorry, begin. Yeah, because we're storing the current position here, then we know this is the first position of this chunk, and then after that we keep reading stuff. So that's why we start from the beginning of the file, and so we just skip this chunk no matter what. Okay. Oh, Visual Studio is hosting. Thank you, Visual Studio. That's awesome. I'm very excited. Okay. So, timestamp, we don't care about that anymore. Then ID. Okay. Okay, the length of the ID is 1. I think it shouldn't be 1. But we can try to read that and see what happens. So if it's not Unicode, then we're going to read this data, like read bytes, length, and then the value here is going to be encoding dot, can be default, I guess. You can try that. And we need to trim spaces and the no terminator characters as well. So we can do something like this, string data, and then, sorry, it's a byte array data, and string value here. Then we use the same things here. Then after that, we're going to return the trimmed value. Okay, this thing should be alright. Let's see. Chunk type 3, size in bytes 0. Yeah, this thing is wrong. Shouldn't be. We need to investigate a little bit more. But we need to chunk the offset, which is okay. It's after we read the size in bytes. Okay, the data offset. So what we need to do is, instead of getting the offset from here, we get it from here. Okay, the position of the stream here. Now it should be fine. Let's run this. Okay, the length now is 67, which is much better. The data is a bunch of numbers, of course, it's bytes, and then the value is unsaved replay, blah 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 blah, and the no terminator at the end. Okay, so you're going to trim that, and this is the ID. Okay, now we need to read other stuff, which is the group and the metadata. They're both FStrings, which is straightforward. So first group, and then metadata. You can have a look at that as well. So we are already reading a lot of stuff from the replay file. For people watching now, just to let you know that I'm going to upload this to YouTube. And you can find my YouTube channel in the links on my channel. So I'm going to upload that later. Tomorrow, probably. So ID group is, player elim. This is a good clue because this is the player elimination event. So we are going to read that. Metadata is versioned event. Okay, that's good. So now we need to read the time of this event, time 1 and time 2, which is uwint32, 4 bytes. So we can do time 1 reader.read uwint32, and then time 2 read uwint32 as well. This is the time of the event in milliseconds. Okay. And then the size in bytes of the data inside of this event. Okay, the data offset. And size in bytes is int32. Okay. We're not going to use this for now. Okay. Let's call this. I'll call this chunk size in bytes. Oops. Okay. So going back to Unreal Engine source code, we don't care about this. All right. So we can try to find this in the hexadecimal editor to have some fun, like player elim, the group. Oh, C# Fritz now hosting my stream with 21 viewers. Thanks, Jeff. Thank you very much. I love your stream. Cool. That's nice. I'm very excited. Cool. Oh, Jeff is asking if there's any latitude or longitude on that struct. I'm not sure. I need to search a little bit for that, but I don't think so. But we can have a look at that. We can try to find that. So we can see here that in this chunk of data, we can try to find the event. Probably it's this one, the event, and then this is size in bytes, which is C0. So C0 here is 192. You can try to grab C0 bytes here. So the length here in the hexadecimal editor says that the length of my selection is C0. So I know that this event data comes from here to here. Okay. So we have some interesting stuff here. So this thing here, for now, it's the most interesting part for me. Like we can see like lep il and 15 ghost 15. So this is nicknames, right? So you can try to go forward. Then you can see the same thing here. Goat fam 59, Spocky main, something like that. Some other player elimination here. Bryce B, Fortnite, and JSZ. So we can see that this is the players. I'm still not sure about which one got eliminated and which one eliminated the other one, but we can try to find that. I have some clues because I'm on this replay file, so we can see where I am, if I'm first or second nickname here. So what we can see about this thing or investigate about this thing is, because inside of the data of this event, it's Fortnite's data. I said it before, I know, but it's Fortnite's data. It's not Unreal Engine's replay data anymore. So only Fortnite can read that and know what's inside there. But we can try to parse it. So we know that we have ID, group, metadata, time on, time to, and size in bytes. And the size in bytes, it's finishing here. So C0, right? Okay. So we can try to find how many bytes we need to skip until we get to the player, the nicknames here. So the ID. Let's have a look at this one and see what's the data inside of this event. Okay, so ID is this big unsaved replay string. So it comes from here to about the no terminator here. And then the next string is player elim, which is B11, right? So it comes to here. The no terminator is here. Versioned event is 15. So it comes to the no terminator here. And then so the metadata is versioned event. Okay, so then we have 8 bytes of times. So this is time 1, 83 4E 0100. This is the same data as time 1. Time 2 is the same data. And then the sizing bytes of this data, which is 75 and 4B, okay? Okay, so you read until the sizing bytes. So the position of the string is here. Okay, so we can have a look at how many bytes we need to read until we get to the nickname. So all the strings start with the length of the string, which in this case lepeil is 7. So we need to skip 2D bytes. Okay, 2D, which is 45 bytes. So we can do something like this. If group equals to player elim, we don't care about writing exceptional code here for now, because we're just trying to read this. Later, when we turn this into a library, a NuGet package, we're going to do a much better work on this code. Maybe try to write some unit tests or something. But for now, it's fine like this. So all we need to do is read the nicknames. So we need to skip 45 bytes until we get to the first nickname in this player elimination, okay? So what we're going to do is maybe we can create another extension method here, which I think it's prettier. Something like skip bytes. This is going to extend the binary reader, and we're going to pass how many bytes, byte count maybe. Okay. Then you're going to do reader.baseString.seek the byte count, and the seek origin will be the current one. So the position we are now skipping the byte count amount of bytes. So reader.skip bytes, and in this case it's 45, right? So when we skip 45 bytes, that's unknown data for us. All of this data here, it's unknown. But I know that Jeff asked me about latitude and longitude, and I don't think it's here because all this data here seems to be the same. If we check the other player eliminations, we can see that this is the same data. So I'm not sure what it is. We need to do some more investigation. But so after we skip 45 bytes, we can read the first name. So we can do like nick1 equals reader.read FString, and nick2 equals reader.read FString. And you can try to see what it is. So for the first one, this should be lepeil, and then 15 goes 15. So lepeil, and then 15 goes 15. So which makes sense for us. The next player elimination is gold fam 59, Spocky main, Bryce, JZ, Groda. Let's see if we can find me here. It should be there somewhere. I know that in this replay file I got the victory royale, so I got position 1. So if I am nick 1 in my first elimination, then it means that this is the killer. Oops. Looks like it's a long time without killing. That's fine. You can try to find it here in the replay file. Let's open it again. Freddy Daddy. That's my nickname. And this is a player elimination. And you can see that my name is second, I guess. Probably this is an Asian name, that it's encoded with different encoding, I guess. Char set. Let's look for the other one. Okay, so the second one is the player who eliminated the first one. Okay, so you can safely assume that player eliminated the killer. Okay, you can safely assume that. We can get some other data. So in this case, Freddy Daddy goes to this no terminator character here, and this next byte here tells us. I did some investigation around that, and I found that this is the type of weapon, the type of gun you used. So 4 in this case, I guess it is a rifle, and you have other numbers for. I think 0 is gas. So when you die to the storm, 1 I think is fall damage. So you fall to your death, and then pistols, shotguns, and so on and so forth. I still need to do some more investigation to make sure of all the data available here. But I'm going to update that, and as soon as I discover more things, I'm going to talk about it in future streams. And this thing here, I don't know why it is whole uint32, which is 4 bytes, but it's essentially it's 0 when you died straight away, and it's 1, like 1 0 0 0 0 0 0 if you got knocked. Like if you're playing squads or duos with another teammate or teammates, then first you get knocked, and then you crawl, and then eventually you die or someone revives you. But if you get knocked, then this thing is 1. So I recorded some squad gameplay, some replay files to investigate that. And this here is another event. It's another player elimination, as you can see here. So you only get the type of gun of the kill, and then if you got knocked or killed straight away, that's what you get. Unreal Engine for unpackers, okay? Yeah, we can have a look at that. Oh, the values for these things here, it's tricky, because when you're playing the game, you can see for every kill in the game, you can see the kill feed. So you can see player X killed player Y with SMG or with a rifle or with a sniper, and then you can see that in games. But I think when you're watching replay files, you don't actually see that. So this makes it a bit tricky. So you need to watch the replay file, and then you need to watch you or someone else killing a player, and you need to know what kind of weapon they are using. So it's a bit tricky. But yeah, we can try to look for some unpackers and see if it helps. But yeah, for now this is good. We can read here maybe the weapon type or gun type. I'm not sure what what to call this. It can read, in this case, a byte, which is this 4 here. But it's not going to make sense now unless we create an enum, something like that. But I need to make sure which number is which gun, which type of gun. So after that, we can maybe try to see the other types of events. So I'm going to add a conditional breakpoint here. So if group is different, oops, sorry, I did breakpoint. So if group is different than player elimination, player elim, then it's going to stop here. Okay. So you need to investigate what are the other group of events in these replay files, because we can find more data doing this kind of investigation. Okay, so this one, player state encryption key, doesn't matter to me. I don't care about that. Okay, this one is Athena replay browser events. Okay, this is, and metadata is Athena match stats. Okay, this is very interesting because yeah, I know we can get some stats from this event, from this data here. So we can try to find this in the in here. So it's Athena match stats, right? Okay. So this is the thing. Athena match stats and Athena replay browser events. And then time 1 and time 2, which should be the same. Okay, Athena match stats. Time 1 here, C4, 6C, and then time 2, which is the same. Okay, makes sense. And then size in bytes, which is 30 in this case, and 30 in decimal. Oh, that doesn't matter because you can have a look here. Eddie Akar. Okay, thank you. Thank you for the follow. Thank you very much. Really appreciate that. We can have a look at this. So 30. So it's from here to about here. Okay. And this 3 here is another event. Okay. So in this chunk of data, we can try to investigate this. I think I did some investigation around that. And since this replay file is from a victory royale, my victory royale, so I know that my position was 1 in this. And but I'm not sure how many people I eliminated in that. Okay, I eliminated 7 people. So I had to open a bunch of replay files, and when you're about to watch the replay file in Fortnite, you can see how many eliminations you have in that replay file. And then looking through a bunch of replay files, I found that this value here is how many people I killed, how many players I eliminated on that match. So I know that we need to skip C bytes, which is 12, in order to get this information here. So in the case that in this case metadata, I'll call this metadata, is this thing here. Then we skip 12 bytes. And then we can get the eliminations. make it 7 people. So you can try to find, to see the value here. Okay, there it is, 7 people. But I did this through some investigation, so it's not very straightforward once you're inside of Fortnite's data. Okay, so the next thing we can read is your position in this replay file. So in this victory royale, of course, I was first. And then you can read how many players were there in the replay file. So this group is encryption key. We don't care about that. And then after that, match stats. That's fine. We don't need that. And then we have this Athena match team stats. Okay, so we need that. Yeah. Match team stats. Okay, so for this one, this is the place where we can read how many your position and how many players were there in the replay file. So you can try to find that here. Okay, it's here. Okay, then the time 1 and time 2, size in bytes 0C. So we can go this one is bigger. Oh, this one is it's not bigger. Yeah, I think it comes through here. Okay, this is another event. Okay, so we can see that the number 1 is here. So this is the position, and 60 is the number of players in that match. So 60 in hexadecimal is 96 people. So 96 people were playing that match in this replay file here. So we can safely skip the first 4 bytes for this one. Skip the 4 bytes, which I don't know what it is. I need some more replay files to investigate. But we know that the position is the next UN32 and total players is equal to read UN32. Okay, and we can have a look at that. Let's run this. Skip 4 bytes, position 1, total players 96. Okay, so it looks good. Yeah, we don't have more chunks of data to read, so that's good. So yeah, here it is. Reading Fortnite replay files, at least player eliminations, all of them, and how many players you eliminated, and your position and the total players in that replay file. You can maybe print some information, like just for the fun of it. So I'm going to create a library. So turn this into a library, a NuGet package, and build CI and CD on top of this, probably using fvar. and maybe cake for the builds So I'm going to do that in another live stream. But for now, we can read this. This is a console app, so we can print data anyway. So we can we have the length in milliseconds of this replay file, but in every chunk we have the time one, which is milliseconds as well. And we can convert this to a meaningful time for us. We can do something like this: string seconds to time, maybe. And let's bring a int or uint. Maybe seconds, it's fine. And then we can use time span, which is I think the easiest thing to convert. So we can get from milliseconds to seconds, and then we can return simply dot. We're going to use this format here, t dot minutes, and then you can use n2, so we need trailing zeros, and then t dot seconds. Sorry, seconds, n2 as well. Or is it D for digit? I'm not sure. I'll try D. Okay. So we can do something like this. Console.write line. Then we can print this thing here, which is time one, right? And then nick1 was eliminated by nick2. Looks good. Let's see what happens. Okay, so you can see the time of the event. So this guy was eliminated by this one. Let's see if you can find me here somewhere. Looks like I started killing people after a long time. That's interesting. Yeah, but you can find that you can see here that I eliminated the last one, the last guy, this one. So yeah, looks good. We can try to see. I have some investigation here. This is my notes. So I have the gun type. I'm not sure about everything because you can be exploded by something like C4 or clingers or grenades. So I don't know every type of gun, but yeah, we can try to maybe do this thing here. And check if we can print out the type of gun. We can do an enum maybe. Gun type. So 0. gas or storm. Doesn't matter. Storm, fall damage, or just fall. So if you fall to your death, then it's going to be 1. This one I'm not sure. I'm not sure if it is pistol. I need to investigate more. This one is shotgun, automatic rifle, AR, SMG, sniper. Oh, there are LMGs as well, the light machine gun. So 0, 1, 2, 3, 4, 5, and 6. Okay, looks good. So we can try to use that. Not fun type. And this should be a byte. Good to be explicit about it. So you can try to use gun type here. And we can try to print this. Oh, wait. Let's see if it works. I'm going to upload this to GitHub. My GitHub is in the links in my channel, the Twitch channel, so you can have a look at that. So you can see that we have some information like SMG, with shotgun, with pistol, 8, I don't know what it is. That's one thing. AR, this is a good thing that I can try to find what 8 is later. So AR, shotgun, ARs. Oh, this thing is maybe it's good to do some data and analytics to see so which type of gun people are dying very often, maybe. So AR, pistol, shotgun, pistol, shotgun, AR, shotgun, SMG. Yeah, lots of shotguns. Maybe shotgun is the first one, the people are most using shotguns. Shotgun 8.8, which we don't know what 8 is. We need to do some investigation. But oh, so he got killed by himself. So probably he just fell. He fell to his death. Yeah, I do this all the time. SMG, AR, pistol, shotgun. Yeah, so as you can see, we can read a bunch of data from the replay file. I'm going to post this to YouTube probably tomorrow, because my internet is not very good here in Australia, so probably you can see the stream is not, the quality is not very good. But yeah, when I move, I need to move to a place with fiber, NBN, 20 megs of upload minimum. So I'm going to upload this tomorrow to YouTube, and yeah, so my YouTube channel is in the links. I think you need to go to my website and then you go to my channel. But we can try to print this. So you eliminated players, and then something like this. Position, and then total players. Let's run this one more time. See all the data we get. So in this replay file, I eliminated 7 people, and then I was the first one the victory royale out of 96 players. Yeah, you can see that the player elimination events, the last one comes after the stats, which is kind of weird to me, but okay. So I eliminated this one with an AR. Okay, so the next step, I want to thank you everyone for everyone that followed me, followed my stream. Thank you very much. I really appreciate that. And I'm going to upload this to GitHub. I have some Fortnite replay reader codes in GitHub now, but I'm going to replace that with this code here that was in this live stream. And I'm going to upload this live stream to YouTube tomorrow. And my plan is to transform this console app into a library, a NuGet package. And I plan to do this in other live streams, so live, and build CI and CD around that, using probably AppVeyor, or maybe you can use VSTS. We need to see, to decide. But yeah, that's it. That's it for this live stream. Thank you again. And if you're not following, maybe follow the stream if you want to get notified for the next streams. And yeah, that's it. Thank you very much. My name is Freddy Machado. I'm in Australia now. It's 10:39 p.m. It's late. And see you next time.